In this lesson, we shall focus on mathematics, Euclidean geometry, grades 11 and 12, and the applications of the theorems that are involved in Euclidean geometry. And we proceed as follows. In the diagram, PQ is the common chord of the two circles. We can see P here and Q there. And indeed, PQ is a common chord, and common chord suggests that it is a chord of the smaller circle, but also a chord of the larger circle. The center, M, of the larger circle lies in the circumference of the smaller circle. There is M. The center M of the larger circle lies on the circumference of the smaller circle, as shown in the diagram. PM and Q is a cyclic quadrilateral. In the smaller circle, QN is produced to R. We're able to see QN is produced to R, and that is clear on the diagram, a point on the larger circle. There it is. R is a point on the larger circle. Moreover, an AM produced meets the chord PR at S. Clearly, we can see the point S over there. Right, the angle PQ equals X. Clearly, the X has been shown in the diagram there. And now, here comes the first question. We have read the story, but they're asking us to answer the first question. Give a reason why the angle N2, right, the angle N2, which is this angle here, also equals X. Give a reason why the angle N2 here equals X. Right, so I'm sure that is a very, very simple question. And so we are right here, right now, and we want to answer this particular question here. Give a reason why the angle N2 also equals X. Right, we're not in a hurry here. We're trying to train your ability to do geometry questions. What is your take, Tando? What do you think? Why do you think the angle N2 equals X? Why? Why do you think the angle N2 equals X? Exactly why is that the case? Why is the angle N2 equal to X in the diagram? Why? The angle N2 over here equals X. Why is that the case? Why is the angle N2 equals X? Why? Why is that the case? Right. Why is the angle N2 equal to X?
By chance, the 10 chord theorem.
Okay, that's fine. But now you'll have to check carefully. Back to grade 11, the theorems that I learned earlier. We cut like this. We do this, and also that. An angle that sits here is equal to actually an angle that sits there. Why is this? What theorem is this?
Exterior angle of a cyclic
Angle.
quad.
Well done. Exterior angle of cyclic quad. Exterior angle of cyclic quad.
Also, can I please just ask which one is the cyclic quad? Sorry.
Okay.
Oh,
There it is. There it is. So you're really able to see that we have 1, 2, 3, 4 vertices, and there's a little tail here. This tail here is this one. And now you can see the angle N2 is this one here, and it is actually exactly equal to this, which is x. But if this is x, also this N2 must be x, because the diagram is exactly like that one. And as a consequence of that, we're able to see that it is the exterior angle of cyclic quad. And we're not in a hurry to solve all the questions today, but I have hundreds or thousands of these questions here. Okay, but we are actually practicing together. We are practicing together. And we proceed as follows. All right, so we can see, therefore, that the angle N2 equals x. Exterior angle of cyclic quad. Exterior angle of cyclic quad. Any question?
Oh,
No question.
yes.
Okay, we move on to the next one. We already know that the angle N2 equals x. Write down another angle equal in size to x. Give a reason. Write down another angle, right, equal in size to x. The examiner is saying there is another angle that is equal to x. We know this one is x, but N2 is also x. The examiner is saying write down another angle equal in size to x. Give a reason. Yep, we're not in a hurry. At the moment, you are the only one on the line. So you're very lucky.
I
So,
saw say,
yeah, what do you
I
think?
see.
If I give you the answer, because I've already solved all these questions, but I want to see what you think about them, you know?
My take is a Q1.
The angle Q1.
It's opposite sides equal angles.
Well done. So we can see that the angle Q1 equals what? Equals the angle P2, which is equal to x. Why? Because MP is equal to MQ radii. MP is equal to MQ radii. Right, you are on point. So indeed, the angle Q1 also equals x precisely, like so. Okay, that is clear. We move on to the next question. We're not running here, we are learning geometry from basics. And we're trying to make sure that we can shine in the geometry assessments. Next question. Determine the size of angle R in terms of x. The examiner is saying determine the size of angle R in terms of x. Angle R is that one there. The examiner is saying find the size of angle R in terms of x. What's your answer? I'm giving you 2 minutes. 2 minutes. 2 minutes. We're not running. We are learning geometry. But now we want to know. We need to determine the size of the angle R in terms of x. What do we do? What do we do? What do you think, Tando?
So from what I can see that we can use M1 and say maybe angles Its center
Angle
equals 2 times.
M1. Yes, angle M1, because this one is already X. So now in this triangle here, in this triangle there, angle M1 is 180 degrees minus double X, because it's minus this, minus that.
Yes.
And the reason for that is
Sum of angles in a triangle.
sum of angles in triangle. So good. So this angle here is 180 degrees minus 2x. I agree with you there. Let me just remove this red paint here. So we have therefore that it is 180 degrees minus 2x, yeah? Which is this one here.
And then say
Then what is R?
we
R,
say
yeah?
angles at center are 2 times the angles at circumference.
So the angle at center is 2 times the angle at circumference, meaning the angle M1 is an angle at center equals twice angle R, angle at center. Angle at center equals 2 times angle at circumference. So angle at center, right, angle at center equals 2 times angle at circumference. Yeah? Angle at circumference, yeah? So angle at center is 2 times angle at circumference. Yeah? So the angle M1, we already know, is 180 degrees minus 2x, which is equal to 2 times angle R by substitution. And we want to determine the size of the angle R in terms of x, meaning we can divide both the left and right by 2. We have 180 degrees minus 2x divided by 2. 2 times angle R, you also divide by 2, like so. Upon careful inspection, we're able to see that the size of the angle R is 90 degrees minus x, like so. So the angle R in terms of x is 90 degrees minus x. Any question about the answer to 10.2.3?
No, sir.
Everything is clear.
Yes.
Okay, good. We move on to the next one, 10.2.4. Prove that PS equals SR. Prove that PS is equal to SR. Okay, so we have this one. Prove that PS is equal to SR, like so. You have 2 minutes to think about it, then we shall discuss it together. But first you need to try, you need to think about it, because you're the only person here. If I had another person, people are tired today. Some are writing English on Monday, so I know very well the September exams are here, the September tests are here. So some of the students are writing English, they told me, so they're not going to be writing mathematics on Monday. So the mathematics is going to be coming like maybe around the 3rd or something. I need to check the timetable. Yeah, so people are chilled. They're relaxing a little bit. They're doing English. But now you have a chance to learn alone. Okay, so we need to prove that PS equals SR. If we need to show that PS equals SR, what do we need to do? Your suggestion. You have 2 minutes to try this. Think about it first. But I know that it's easy. We already have the answer anyhow, but I want to see what you think about it. I want to see what you think about it.
I know that PRC is a code.
Yes, we know that PR is a code because M is the center of the circle. M is the center of the larger circle. Right, that we know. And PR is a type of code that is, it doesn't pass through the center of the circle, and therefore it is not a diameter, for example. just to mention, okay? We're just mentioning it, that PR is not a diameter. If it were a diameter, perhaps it would, we know about diameters. We love diameters because they have special properties in geometry. But now it's not, okay? Yeah, but okay, it's an observation, yes? So the question is, the examiner said we must prove that PS is actually equal to SR. Yep. You have 2 minutes. We are alone here. We are here until 10:30 tonight, at least, or we go beyond 10:30. There are too many questions I've prepared today, but like a lot. But now, what do you think about this question? 2 minutes.
Okay.
2 minutes. You relax, and you think about it, and let me know when you got the answer. Because I'm not going to move on until you tell me. But I'm saying do not rush. Have your pen, paper, think about it, look at the figure, think about it, and give me a suggestion. But don't rush. You're going to break your bones. This is not good. It's not good to break your bones when you're running. How far, Tando? Right, we know that in triangle NSR, in triangle NSR, like this. Right, in triangle NSR, we know that the angle N2 is already X. The angle R we know is 90 degrees minus X. So that now the angle R is 90 degrees minus X. This one is X. So in other words, we already know that in triangle NSR, the angle R is equal to 90 degrees minus X. Simultaneously, the angle N2 we already know is X. This one has been proved. It has been proved above. Right, so in other words, we know the X and the 90 degrees minus X. So now we can find the third angle, the angle S2.
Okay.
Yes, please.
So I was seeing that I think S1 is also an exterior angle of the triangle
Yeah, that's brilliant. Yes, that's correct. Yeah, I agree.
And I was going to add S1 to S2 because of adjacent angles on a straight line.
Yeah.
But okay.
Yes, you can add them up. S1 plus S2, you get 180. Correct. Yes, I agree. So S1 plus S2 equals 180 degrees. So you agree? Yes? So, okay, that's another way to do it. It's an exterior angle, I agree. But also, just look at the triangle NSR alone, NSR, we can be able to add these together with these, and get 180 degrees. So the angle S2 is 180 degrees minus 180 degrees minus these two angles. Ninety minus X. So that we have angle S2 equals, okay, this is X minus X, which is 0. And then 180 degrees minus 90 degrees is exactly 90 degrees. What a beauty. Now, this is awesome. So we have, therefore, that the angle S2 actually exactly equals 90 degrees. Like so. Exactly like so. Upon careful inspection, it is therefore clear that this angle S2 is 90 degrees, but also you can say that S1 is also 90 degrees because these are adjacent angles on a straight line. But this is enough to allow us to make the conclusion that PS is actually equal to SR. So we're saying PS equals SR, and the reason for that is line from center. Line from center, perpendicular to chord. Line from center, perpendicular to chord. Line from, there's a theorem. The theorem says that line from center, perpendicular to chord, bisects the chord. So in other words, there's a theorem that is clear about the fact that if you have a circle like this that is done at grade 11, if you have a circle like this and there is a line from the center of the circle, be it center O, and that is such that it is perpendicular to the chord, because you have a line that is perpendicular to the chord, it therefore does what? It bisects the chord. If this is the case, what you then have is therefore that you'll have the circle like so, and you have what you call perpendicular bisection. You therefore have what you call a perpendicular bisector, and you have exactly this, like so. Okay, so we're in business. We are in business like this. So if you have a perpendicular line from the center, in other words, line from center perpendicular to chord, line from center perpendicular to chord bisects the chord. Bisects the chord. Bisects the chord. So, okay, yep. So we've proven that PS equals SR. You're the only one on the line, Tando. Please think about it and let me know. What is your question? Make sure you understand exactly what to do. Make sure that you understand precisely what needs to be done here. This is the kind of stuff you're going to meet in the exam. I must tell you honestly, these I've taken from grade 11 past exam questions. Grade 11 exam questions. Term 3, Term 4 exams. Term 3, Term 4 exams. That's where I took this from. Okay, it's not that I'm just doing it. Term 3, Term 4, this is what you're going to meet in the exam, the kind of stuff you're going to meet in the exam. So you need to make sure you understand what to do. And this is going to help you to improve your math mark, because your geometry is everything. Geometry is about 50 marks in paper 2. So you're going to meet it at grade 11, but also at grade 12. You're going to meet geometry. So it's very important. Any question, Tando? No question. Anything you don't understand? Anything you'd like us to explain?
No, sir.
Nothing. Everything is obvious.
Yeah, I can
Okay.
see.
All right, that's okay. All right, never mind that because I want to give you a chance. You're the only person here right now today. Okay, as I said, my students will be writing English. We'll be writing English. Okay, let's move on to the next question. So now you're gonna think about it, then we discuss. The way to do it is like that because I don't want to just bombard you with everything. I don't want to just bombard you with everything. Okay, let's look at this one. O is the center of the bigger circle. We have that O is the center of the bigger circle. There is O, and is the center of the bigger circle. O lies on the circumference of the smaller circle. So there's a smaller circle. On the circumference of the smaller circle, O exists, and O lies there on the circumference of the smaller circle. But there's OWVU. OWVU, a point on the circumference of the smaller circle. Right, so you can see OWVU clearly a point on the circumference. 1, 2, 3, 4 on the circumference of the smaller circle. TSVU a point on the circumference of the bigger circle. TSVU are sitting on the circumference of the bigger circle. Pay attention. Name 4 other angles, each equal to X with reasons. Okay, so you have 3 minutes to think about this one. I'm not rushing you. I'm not rushing you. I'm giving you a fair chance. So, chill. We're not in a hurry. And then when you think you have because there might be 4 of the angles. So if you think you found one, you say I found one. You say I found one. You say I found one. We're not running, we're not in a hurry. So yeah, take a chill pill, relax, sit back, and try to find the angles. How far?
I managed to find only 2.
Okay, that's fine. That's okay, Tando. We're not running. Just give me one for the start. One angle. One by one, obviously. One at a
S1.
time. The angle S1 equals X. Very well done. So we have that the angle S1 is equal to X. Why?
Angle at center is equal to 2 times the angle at
Very
center.
well done. So angle at center.
Sorry, it's
Angle at
circumference.
center. Yes. Equals 2 times angle at circumference. Yeah. Equals 2 times angle at circumference. Yeah. Next.
We have I see the what's this one? I think S1 and V3 because
V3.
yes,
Good. V3 equals X.
angles in
Angles
same segment.
in well done. Angles in same segment. I agree. Okay, we're analyzing this question. These are from grade 11 past exams. Grade 11 past exams. Yeah. Next, the examiner is saying there are 4 of them. He's saying there are 4 of them. So we're missing 2 more. So you can see that this one is also X, which is V3 is also X. The examiner is saying, hang on, students, there are 2 more. Can you find them? Yep.
There is also I think I see W1.
Well done. That's brilliant. Brilliant, brilliant, brilliant. Yeah. I agree with you, Tando. W1 is also the same. And it is one of those angles we need to celebrate the most. It's one of those angles we need to celebrate the most. I agree with you, Tando. The angle W1 also is actually X. Okay, I'm going to write that one down, but the examiner is saying, hang on, there are 4. Just give us 4. So in other words, we're missing one more angle. One more angle.
Uh,
Yup. I agree with you, Tando. I agree with you. So W1 is also X. Yeah? W1 is also X. That is wonderful. So we're able to see that the angle W1 is actually equal to the angle V3, which is equal to X. Angles in same segment. Angles in same segment. Yeah? Next. We're missing one more. If this one is X here,
so I was thinking U1.
okay? You think the angle U1. Why will that be the case, Tando? Why would that be the case, Tando?
Oh. Mm, 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 mm.
Right, we're missing one more angle, Tando. One more. The examiner said there are 4 of them in this grade 11 examination. This grade 11 examination, the examiner said there are 4 of them. So we're missing one more, Tando.
I wanted to say that the entire angle U is equal to X.
The entire angle U equals X. Very, very well done, Tando. It is the entire angle U that is X as well. I agree. So the entire angle U here is also X, because this one is 2X. And 2X must be this plus this. So in other words, it forces the entire angle U to be exactly X. In other words, the angle U equals X. The reason being exterior angle. Right. Exterior angle of triangle OVU is equal to the sum of opposite interior angles. Interior angles. Interior angles, y'all. So we're done. We are done. We are done. So we have S1, W1, V3, the whole of U. We have S1, W1, V3, the entire angle U. All those are X. Right, in 10.2, determine the size of W2 in terms of X with reasons. The examiner now is saying we need to find W2 in terms of X, but with reasons. W2 in terms of X with reasons. W2 in terms of X, but with reasons. But with reasons. With reasons. Okay, think about it then and let me know as soon as you're done. Yeah, think about it and let me know as soon as you're done. Okay, you have 1 minute there. Okay, yeah. Hello, Tronjay. Fine, thanks, and you, Tronjay. Yes, please, Tronjay. Yeah, I'm in class now. I'll check with you tomorrow. Oh, All right, yeah, that's fine. Yeah, I'm still in class now, but I'll check with you tomorrow for sure. Okay, thanks, Tronjay. Right, how far, Tando?
Almost there.
All right.
So the reason why I said I'm attending the lesson a bit late was because the teacher was explaining to us how the ideal guesses. So I'm thinking that I understand now, meaning that I'm already on slide 4 of the thing, and it's going pretty well. So I don't know if we're still gonna do the ideal guesses or if we're gonna leave it behind, or maybe we can do the ideal guesses for an hour, maybe.
Okay, Tando. Right, welcome, Perelelo. Right, so yeah, I understand the so it's okay if you're on slide 4. I heard that. So, but obviously the due date is tomorrow at 11 p.m. So I'm giving a couple of alternatives, I think. So yeah, for today, see how well you're able to do. And let me give you a chance today to think about the ideal guesses. And then you let me know how it goes today. But I'm beginning to think that since obviously you have already started the ideal guesses, it's pretty fine. But what we can do for the ideal guesses, grade 11 syllabus, I'm gonna give you a couple of time options, right? Because you said it's due at 11 o'clock 55, like 11:55 p.m. tomorrow night. Right. So you have a couple of options. 4 p.m. 4 p.m. tomorrow afternoon. If you're busy at 4 p.m., 6 p.m. In other words, 4 to 6 tomorrow afternoon, or 6 to 8 tomorrow afternoon. Or obviously 6 to 8, that will be tomorrow evening. Where we will look at the ideal guesses from beginning to end to acquaint you with the kinds of concepts you need to know about the ideal guesses so that you can prepare for the assessment. And then, so you'll choose your times there because we can also dedicate time as well between 8 o'clock and 10 tomorrow evening, looking at the ideal guesses as well. You'll have an opportunity to ask if you have challenges with the assessment given to you by your teacher tomorrow. Okay, so we have a couple of time options. 4 to 6 if you're busy, 6 to 8 if you're busy, 8 to 10. We can have a discussion on that, and also you can ask questions if you have the things. Yeah, but again, you're on slide 4, and you said those slides are such that you can't go back. You can only move in one direction, right? So you see, that's the kind of thing. But think about it and let me know. But yeah, let's give you today a chance to think about it. Then we'll devote more learning time, like teaching time, from the basics of ideal guesses to practice questions on ideal guesses, Charles's law, Boyle's law, and so on and so forth. Okay, so think about it. It's fine. It's fine. So I'm giving you a little bit of time to think about it. But now we are thinking about these type of questions today, or right now at the moment. Right. So let us think about this and see how best we can tackle this. The examiner is saying that we need to determine the size of W2 in terms of X. I know that we are finding us in the middle of this discussion, parallel, but yeah, this student requested that we discuss this in the meantime. But if you are busy with the ideal cases, I mean, you are allowed to You're allowed to focus on the ideal gases. But I know you still have a lot of time until tomorrow night at 11:55. So you have like the whole of today evening and the whole of tomorrow daytime. So yeah, think about it. It's okay. You still can chill and do the geometry. I decided to do the geometry because these other students will mostly be writing the second paper this coming week. And so it will be very important to just cover the paper 2. So I'm making every effort to cover the paper 2. Because there's some students who will be writing a test on math paper 2 this coming week. Right, but there's a question that they asked here. So yeah, we still have a lot of time, but I'm
Right.
giving What do you think are the Tando? It's like you have an idea.
I only have an idea. So the only thing I can see is that
Yeah.
O2, I see it's 180 minus 2x because O1 plus O2 is equal to 180.
Well done, well done, well done. So you're able to
So
see that the angle O2, and that is very, very important. So you're able to see that at this point in this triangle here, this triangle that goes this way, it also goes further down and goes this way as well. You're able to see that this angle is x, that is x, and then you can find this angle there. And this is the angle O2. So you're able to see, therefore, that the angle O2 equals 180 degrees minus double x. Why is that the case?
sum of angles in a triangle.
Right, this is the sum of angles in a triangle. Okay, sum of angles in a triangle. We're good. We
Don't you
pay,
say?
yeah, and then what else do you see, Tando?
What I noticed is that O2 is equal to W2 because of angles in same segment, I think.
Yeah, that it is. That is it. There it is. There it is. You got it, Tando. You got it. You got the examiner. Right, you got the examiner because this is 180 minus 2x. In other words, the angle W2 is the angle O2, which is 180 degrees minus 2x. Yeah? And why is this the case, Tando? Why is W2 equals O2? Why?
Angles in same segment.
Angles in same segment. Angles in same segment. Right, angles in same segment. Very well done there, Tando. And we move forward to the next question. The next question is as follows. So we have S1 is X, W1 is X, V3 is X, but also U1, U2 are both X. The angle O2 is 180 degrees minus double X. Okay, so we have that. So we have that S1 is X, W1 is X, V3 is X, the whole of U is X, and this one is 180 degrees minus 2x. Like so. Next, 10.3, prove that WS equals WV. WS equals WV. WS equals WV. Prove this. You have 3 minutes with parallelo. We have 3 minutes parallelo. So if we need to prove that, remember guys, this is a grade 11 past exam. These are grade 11 past exam questions. I've just put them together. I chose like serious questions that will make you think a little bit on geometry. I want you to master geometry, but the way to master geometry is to try a couple of questions. I have with me hundreds of questions that are going to last us until after 10 tonight. Until after 10 tonight.
Say, I have a question, sir.
What's your question, Tando?
By chance, is VU a diameter of the smaller circle?
Question is VU Right. Is VU a diameter of the smaller circle? Is that the question?
Yes, sir.
Okay, yeah, that's an interesting question, but they did not tell us. And so there's no indication. There's no indication about that. Okay, if I lose you, please reconnect. If I lose you, in case I lose you, please reconnect. And just in case I lose you, connect again. Okay, we are asking the question, Tando, is VU a diameter? Well, we're not given, we've not been told, so we would have to prove that, and hence we don't know yet. We don't know yet. We don't know yet if VU is a diameter. We don't know yet. We don't know yet. But now we're asking a question. Prove that WS is WV. Prove that WS is WV. Okay, here is W, here is S, here is V. Prove that WS is WV. Like that. Prove that WS is WV. Too easy. Very, very straightforward. We need to prove that WS is WV. Right. Prove that WS is WV. Right, your take. You have 2 minutes with Tando, with Parallelo. Parallelo and Tando, you think about it. I know that I've been with Tando for some good time already this evening, but Parallelo is here, and here are the grade 11 geometry questions want to practice, but yeah. I must indicate that tomorrow evening, because Tando does science also, we're going to spend a lot of time during this time to do ideal guesses. I think I must say that in advance so that you can prepare. And then you can ask questions that are troubling you on ideal guesses at this time, but we're going to present a lesson. But we're going to try lots of past exam questions on ideal cases and everything on ideal cases at this time, during this time tomorrow. But I know because the deadline is 11 p.m., so that's why I'm giving you earlier times. You can do 4 to 6 p.m. so that you can finish the things early. If you're busy that time, 6 to 8 p.m. Otherwise, 8 to 10 p.m. Right. So during the 8 to 10 p.m. slot, you can ask the questions that are troubling you on ideal cases because you'll be discussing ideal cases. But the best would be if you can, if possible, you can send your questions on ideal cases so that we can like have the questions on time, and then we can if you had some pictures of the questions. But I know that you said the questions are on slides and things like that. So yeah, okay, yeah. But I'm trying to make sure we have the questions early. Okay, I'm talking to Tando, but yeah, I lost Pekalelo. I lost a student who is interested in the ideal guesses. So want to prove that WS is actually WV. WS, it's WV. Right. How far, Tando?
I am stuck, sir.
Okay, we need to prove that WS is what? Is WV.
The only place I managed to see, sir, is that
Saying what?
I said the place where I managed to reach is the point that W2 is an exterior angle of a triangle SVW,
Yeah.
and I know that S2 plus V1 and 2 is equal to W2.
Okay, first things first, yeah, you're right, Tando. This angle here is how many degrees? Because now you know that O is the center of the bigger circle. So O is the center of the what? Of the bigger circle. So if O is the center of the bigger circle, what does it mean?
That S is 90 degrees.
S is 90 degrees. Very well done. And that allows us to say the angle S is actually equal to 90 degrees. In other words, you're able to say that the angle S1 plus 2 is 90 degrees. It is an angle in semicircle. Yeah, 90 degrees. So that this one is 90 degrees minus X. So that therefore, we can then say that the angle S2 what is the angle S2? 90 degrees minus X. So yeah, there's just no apparent reason there because you already know this one is X, and therefore this angle S2 is 90 degrees minus X. Next.
Oh, so I think I'm at a
Uh-huh. You think we're seeing something?
yes, sir. Please give me just 2 seconds.
All right, Tando.
Okay, sir. So you
Yes.
said S2 is what's this 90 minus 90 degrees minus X, sir. So
Uh,
what I did, sir, I said
yes. Mm-hmm.
since W2 is the exterior angle of a triangle SWV,
Yeah.
I said S1 plus S2 is equal to W2 exterior angles of a triangle.
Yeah.
Then, since we have the value of W2, I did my algebra and I concluded that V2 is 90 degrees minus X.
Yeah.
And V1 and S2 are equal. So if they are opposite, angles opposite equal sides,
Yes.
hence proving that SW is equal to VW.
Okay, very well done. You're really on point, Tando. So in other words, you're able to see that, as you're saying, first things first, sir, is to note that the angle W2 is S2 and it's S2 and what? And V1. Okay, you can write that one down. So you can be able to observe that the angle W2 is equal to the angle S2 together with what? Together with the angle V1. Right, and the angle W2 is S2 plus the angle V1, and this is what? This is exactly exterior angle of triangle. Exterior angle of triangle. Now, at this point, it is clear that you have, for example, you can find the size of the angle V1 and this means that the angle V1 is actually the difference of those other angles there. So in other words, it means that the angle V1 is equal to the angle W2 minus the angle S2. And what is the angle? So that you can then say the angle V1 is actually obviously W2 minus S2. And you're able to make the observation that the angle W2 equals what precisely? For example,
180 minus 2x.
Well done. You know that this angle W2, we got it before. It is actually the same as this one, which is 180 degrees. 180 degrees minus 2x. So you put it here, which is 180 degrees minus 2x. What is the size of the angle S2?
90 minus x.
Well done. It is exactly 90 degrees minus x in parentheses, like so. 180 minus 90 is what?
90.
90. And then you have minus 2x plus x is minus x. That gives us the angle of V1 to be actually exactly 90 degrees minus x. So that in the end, you have that SW is actually equal to WV. So that now you have, because now, and this is the case, means that you have the sides. The reason for this, you have sides. Sides opposite equal angles. Sides opposite equal what? Equal angles. Right. So any question on this one there, Tando?
No, sir.
No question. Right, we move on. Once again, we have tons, but a lot of practice questions for us. And move forward to the next one. Move forward to the next one. Right, here is one more question on geometry. This one is pretty straightforward, but a bit soft. And the question reads as follows. In the diagram, MP is the diameter of a circle. MP is the diameter of a circle centered at O. The center is O. And MP cuts the chord and R at T. We can see T. Radius and O and chords PR, MN, and MR are drawn. The angle R1 is 69 degrees. R1 is 69 degrees. Determine giving reasons the size of the angle R2.
Sir, I already know it, sir.
Right, what do you think the size of N2 is and why?
Okay, so since we have that O2 is a point, sorry, O is a point of the center.
Yes.
Angle R is gonna be equal to 90 degrees.
Yes, the whole of R, the entire angle R, it's 90 degrees. In other words, the angle MRP is equal to 90 degrees. Why is this the case? It's an angle in semicircle. Next.
And then R1 plus R2 is equal to 90 degrees.
Right. So in other words, R1 plus R2 is 90 degrees. Yep. Then what is the angle R2?
It is 21.
It's 21 degrees, which is actually exactly 90 degrees minus 69 degrees, which is exactly 21 degrees. Yeah. So in other words, the angle R2 is 90 degrees minus 61 degrees, which is actually equal to 21 degrees. Yep. Okay. So we're good. We're good. Right. We agree with you there. And then we're off to the next question. The angle O1. That's what we're trying next. That's what we're trying next.
I'll say O1 is 138 degrees.
Why?
It is 2 times the angle at circumference.
Good. Good, good, good. Right. So the angle O1, so you have something like this here. Something exactly like so. So that the angle O1 is 2 times the angle 69 degrees. And this is 138 degrees, like so. And what is the reason?
Angle at center
Angle at center.
is 2 times angle at circumference.
Yeah, so angle at center equals 2 times angle at circumference. Angle at center is 2 times angle at circumference. Yeah? Next. The next one is the angle M1. So we're done with the angle O1, but now we need the angle M1. Right, so let us find the size of the angle M1. Too easy. We're not running. We're not in a hurry. We're taking our time. There are too many questions we have with us to practice geometry today. I said the other student requested that we do ideal guesses tomorrow. So yeah, we're gonna be doing science tomorrow at this time. But now, angle M1 is the question. Angle M1 is the question. We're not running. I'm giving you a chance to think, then we shall discuss, because with me, I've already solved all these questions. So I already know what to do, because I've solved everything. Yes, please.
I say M1 plus N1 is equal to O2.
Yeah.
And I got the value of O2 by adding O1 plus O2 because of adjacent angles on a straight line.
Yeah.
And the value of O2 was 21. No, sorry, 42.
Yes.
And O2 is an exterior angle of triangle MNO.
Yeah. I agree with you.
I think M1 and N1 are equal because they are radii.
Yeah, yes, that is true. Yeah, I agree.
So in my conclusion, so M1 is equal to 21 degrees.
Very well done. Very well done, Tando. There it is. There it is. So in other words, the angle M1, right. So the angle M1 is exactly 21 degrees. And the reason for this is that these are angles. Angles opposite equal sides. Right, so you can actually be in a position to say that, but the easiest way, I mean, I wanted to say that, but I would have to put a bit more details here. But we already know that the angle R2 is already what? The angle R2 is 21 degrees. And we know this here. We know this here.
Oh.
Right, so this kind of a shape, it's like the bow tie shape, and it's for angles in the same segment. You already know R2 is 21, and therefore this is also 21 degrees. And you can then say the angle M1 is 21 degrees because these are angles opposite, I want to say angles in the same segment. Excuse. So you then say angles in the same segment. Angles in the same segment. Angles in the same what? Segment. Angles in the same segment, yeah? So we're done. Angles in the same segment. So we're done.
Yeah.
Right, but now we have one more question to answer. And it is 8.1.4. The angle M2 is now the question. What is the size of the angle M2? If it is further given that NO is parallel to PR, NO is parallel to PR. Right, M2, if it is given that NO is parallel to PR. Right. So there it is. There it is. So we need right now the angle M2, and you have 2 minutes to find this one, Tando. Right, good, parallelo. Good, parallelo. Once again, we'll make a lot of available slots to discuss the ideal gas theory, to discuss Boyle's law, to discuss Charles's law, to discuss computations on the universal gas equation, the computations that involve pressure, volume, and temperature relationships. Okay, and we shall discuss that. And the fact that if you increase pressure, we anticipate volume to decrease. So if you increase pressure, volume decreases, but this happens only at constant temperature. When temperature is kept constant, volume and pressure are inversely proportional to each other. It's the kind of relationships we'll discuss, what you call the inverse proportions. But now the ball game changes when you start changing the temperature. And now, when the temperature is not constant, we cannot say that volume is inversely proportional to pressure. That kind of thing. Right. And yeah, these are interesting things that we'll discuss how a balloon with helium inside it, or a balloon with hydrogen inside it, is able to lift off the ground. Is able to lift off the ground. But we're able to discuss why is it that in hot air balloons, okay, they were what you call the hot air balloons. Right now, shall discuss this tomorrow. Let's just think about this one, Tanda. So we shall discuss the hot air balloons. There are these kinds of the balloons like that. And now these hot air balloons, you find them like this. And then here they have a little basket here. And then there's somebody in the basket. There's somebody in the basket, but these balloons now, they lift off full of helium inside. Okay, they're full of helium inside, and then they lift off the ground. They'll be going up high with helium there. And we shall discuss why this happens. Okay, right. But anyhow, this is what is going to help Tegelelo. Please, in case you're disconnected, please rejoin the discussion. Join the discussion because it's all technology. If you disconnected, it's technology. We don't reject people, but we accept people. So if you're disconnected, we don't know why sometimes. Network, whatever the reason. So always try to reconnect again. Right, we are interested in then determine given reasons the size of the angle M2. The size of the angle M2. Right, you are trying that one, M2. You're trying to find M2, and M2 is this angle here. There are some of the angles that you already know, like you already know that the angle O1 here is 138 degrees, 21 degrees, 21 degrees. But we want to find, for example, the size of the angle M2, this one. Right, okay, yeah. We need M2. We need M2. Tando, what is the size of the angle M2, Tando? I'm asking you because you've been here, and I'm sure that Takalolo is looking at this diagram. It's like, okay, he's looking at this figure, he's wondering what's happening. But Tando has been looking at this one for the longest time. But we're asking the question, what is the size of the angle M2? What is the size of the angle M2? Tando, what is it? Right, Pehelelo, what do you think? M2. You might do magic. Pehelelo might do magic here. Okay, but you want to find the size of the angle M2.
Okay.
What do you think?
What?
Pehelelo, what is the answer? Oh, okay, I lost Pehelelo. Yes, Tando.
I got 21.
You got 21 again. 2-1.
Yes.
Okay, that's fine. That's fine. We're gonna check together. We're not running here. We are not running. Okay, there are a couple of things you need to take into account. It is the fact that we can actually be in a position to get the size of the angle O2, this one.
We already have O2, sir.
What is the size of the angle O2? Yeah?
It was 42 degrees.
Well done, 42 degrees. And why is it 42 degrees?
Adjacent angles in a straight line.
Yes, it is angles on a straight line. Angles on a straight line. You can say adjacent angles on a straight line, yeah? Okay, you can say adjacent. Adjacent angles on a straight line, yeah? And then now, okay, you have that, therefore this O2 is 42 degrees, yeah? And then now what is the angle P? It's 42 degrees. Why is the angle P 42 degrees? Why?
Is it, because NO is parallel to PR.
Yes, definitely. So those are alternate angles. They are alternate angles because NO is parallel to what? To PR. NO is parallel to PR. NO is parallel to PR, and those are alternate angles. Yeah, next thing. Next thing.
When we add everything together, so we can just use a triangle MPR.
In triangle MPR. Well done. I wanted to hear that. So in triangle MPR, we know therefore that the angle M2 we want, the angle M2 that we want is equal to what? 180 degrees minus what? 180 degrees minus what exactly? 180 degrees minus 42 degrees minus what? Minus 42 degrees minus the rest of this angle here, which is minus 90 degrees, yeah? So we have the angle M2, which equals that. What is the answer? 180 minus 42 minus 90. What's the answer, Tando?
48.
Yeah, I believe you. 180 minus 42 degrees minus 90 degrees. The answer is actually 48 degrees. So we're 48 48 degrees. That is it. 48 degrees. So M2 is actually equal to 48 degrees. And this is what we get. And the reason for this here, the fact that we're saying 180 degrees minus this, is because of the fact that it's sum of angles in triangle. Right, this is sum of angles in triangle. So sum of angles in triangle. That's why we have 180 degrees minus 42 minus 90. Sum of angles in triangle. Sum of angles in triangle. There it is. Sum of angles in triangle. Right, so that's what we get. That is what we're able to achieve here. Sum of angles in triangle. Sum of angles in triangle. Yeah. Okay, we find we got M2 to be 48 degrees, and then we move on to the next question. In the diagram below, ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. AB and DC are produced to meet at E. There is E. AD and BC are produced to meet at F. There is F down there. Now, the angle AFB is 2x. AFB, the angle is 2x, but DAB is 3x. Right, we have DAB is 3x. And the angle AED is x. AED is x. Determine giving reasons the value of x. Determine giving reasons the value of x. Determine giving reasons the value of x. Right. So, think about this one, Tando. Y'all let us know when you're done. Right. Okay. Right. How far are you, Tando?
Not too fast.
All right, that's fine. We're not running. We're not in a hurry. We have the whole evening here to solve this particular question. But good luck, you by yourself, because this other student couldn't stick so much around yet. The other student couldn't stick around so much yet. Right. Right. We're here learning geometry. We're learning geometry. Right. Learning geometry. Right. All right. We're here still. Right. We're here. We are here. Right. We want to get the value of x, Tando. Right. Right back. Want to get the value of x. So we're practicing, Tando. So we're not running. When we're practicing, we don't run. We take our time. So we chill. We don't run when we're practicing. Right. When we're practicing, we do not run. And we just want to get the value of x out of this. Right. Yeah.
So,
Yes, please, Tando. How far?
uh, x is 20 degrees.
Okay, x is 20 degrees. How did you do it, Tando?
I started by, okay, I expressed B2 as 180 minus 5x,
B2 is 180 degrees minus 5xy, Tando.
because of sum of angles in a triangle.
Sum of angles in a triangle. So this is 180 degrees minus 5x, right? So that's what you're writing. Minus 5x. So B2 is 180 degrees minus 5x. The sum of angles in triangle. Next.
Then, what I say,
What about D2?
Angle D2.
Now the angle D2 is also 180 degrees minus what? If you look at this here, if you look at this triangle, what is the angle D2?
Oh, it is 118 minus 4x.
180 degrees minus 4x. Well done. Why, Tando?
The sum of angles in a triangle.
Sum of angles in triangle. Yeah. Next. Want to find x.
So you can try to express what thing. You can try to say let me see.
Yeah.
Also, opposite sides of a cyclic quad are equal to 180 degrees.
So the angle B2, yeah, the opposite angles of a cyclic quad are supplementary. So in other words, the angle B2 plus the angle D2 equals what? 180 degrees. Opposite angles of a cyclic quad. So now you have B2. What is B2 here, for example? It's 180 degrees minus 5x. The D2 is 180 degrees minus 4x, and the result is 180 degrees. 180 and 180, you can cross out. 180 and 180 degrees cancel out. And this lead us to having the following. So we'll have 180 degrees equals, now minus 5x minus 4x is a 9x. Divide by 9. 20 degrees. X equals 20 degrees. So very well done to you for getting 20 degrees there. Yeah, any question about this one, Tando?
I don't.
Is it very clear?
Yes, it is.
Okay, good. Let me see what other question exists. Okay, once again, this discussion is recorded. Right, the next one is this one here. And so you think about it and make sure you sort of have an understanding of this, because it is a very, very important one. So now this one is your home activity. This one is your home activity. And then we have some science to do. The other student was interested in science, ideal gas laws, and Boyle's law, and pressure, volume, temperature relationships, and the ideal gas equation. So those are the kinds of things that other students spoke about and was interested in them, and it will make sense for us to spend some time tomorrow to discuss that during our set of lessons, in particular in the 8 p.m. in the 8 to 10 p.m. slot. Right, so in the 8 p.m. 10 p.m. slot, we are planning to do the ideal gases and other things. So obviously it's something that I'm sure will benefit both of you. The other student is doing grade 11 and also Tando is doing grade 11. So yeah, it's very, very uniform. This one is in the diagram. TSR is the diameter of the largest circle, having center S, right? Chord to Q of the largest circle cuts a smaller circle at M. There is M. Now PQ is a common tangent to the two circles at Q. There's Q and SQ is drawn. We have that. RP is perpendicular to PQ. RP is perpendicular to PQ. And MS is parallel to QR. MS is parallel to QR. Proof giving reasons that SQ is the diameter of the smaller circle. SQ is the diameter of the smaller circle. RT is RQ squared over RP. So RT is RQ squared over RP. Right, anyhow, this one is your home activity there. So think about it there, okay? So, yeah, we're going to spend some time discussing these things moving forward. But we'll also have science to discuss tomorrow. Right, I must thank you, Tando, for joining us. It was awesome having this discussion. Until tomorrow, take care and have a good evening. This recording is going to be made available and it's going to be sent so that you can pass through and see how well you attempted the questions today on geometry. I'm sure that it was very, very useful. But thanks again. Until tomorrow, take care and goodbye.
Oh, goodbye, sir.
Goodbye, Tando.